Hi, I'm Erica Carlson, a theoretical physicist at the Purdue Quantum Science and Engineering Institute. Welcome to Quantum Connections, where we have interesting conversations with scientists and engineers working on all things quantum. Our guest today is Dr. Smitha Vishveshwara. Dr. Vishveshwara received her PhD in physics from UC Santa Barbara, working with Matthew Fisher. After that, she went on to do postdoctoral work with Paul Goldbart and with Nobel Prize-winning physicist Tony Leggett. She's currently a professor of physics at the University of Illinois in Urbana-Champaign. She has several awards. Just to give you a sense of a few, she's a fellow of the American Physical Society, a Simons Fellow, a Beckman Fellow, and we'll get more into this towards the end of our segment today. Smitha has several collaborators in the theatrical arts as well. And so she'll tell us a little bit more about that at the end. The first thing we want to ask you is, what originally inspired you to be a scientist?
First off, Erica, thank you so much for having me here at your Quantum Coffee House. It's wonderful to be sharing. I think it was a lifelong inspiration, along with fellow explorers, scientists, mentors, mentees, perhaps beginning even pre-birth. My mother is a quantum biophysicist. My father was a black hole physicist. And in India, the alternative school that we went to really encouraged exploration, science, arts, dialogue, a whole way of life. Then as an undergrad at Cornell, I used to do physics during the day, and I would do the arts, creative writing, theater, and the like at night. And I think the real taste for research really came as a graduate student in Santa Barbara, as you mentioned, exploring condensed matter theory. I'm a pen and paper physicist. I could, of course, do that on the beach, but that was when the real toil began. And my first glimpse into sort of really the depth and miracles of the quantum world. And from when I've been in Illinois, that gets deeper and deeper. And just understanding quantum in its conceptually, mathematically, the incredible experiments that are out there, and even technology, everything from the devices that you have to MRI to the future in terms of quantum bit technology, all of it put together is something so exciting. It's a lifelong inspirational journey.
That's great to hear, Smitha. So you do a lot of great research. I've heard several talks that you've given over the years at conferences with you and at seminars. Of all the great things going on right now in your research program, can you tell us one thing that you're most excited about right now?
So the quantum world's fascinating. The microscopic world, nothing like what we see. Particles, matter and light can both behave as particles or waves. They can exist in different states at once. Magnets, protons in your body can either point up or down at the same time, a superposition. They can exist in up and down at once. Now, as condensed matter physicists, you and I think one of the really exciting things is how when you put all these building blocks together, what emerges? What is the collective behavior? For instance, the wave in the stadium, we're all made up of individuals, but when we come together, we do something so different that is much bigger than the sum of the parts. So in condensed matter, that's something that we all love, enjoy doing. And what's amazing is that we are able to experimentally access these quantum states of matter where you see things on macroscopic scales. Superconductors, for example, or the coldest states in the universe, not out there in space, but really in labs of experimentalists where they can get to nanokelvin and create really, really cold states of matter. So the thing there are many things along in this whole realm that I'm interested in. And if I were to name one or two, one is trying to look at the strange creatures that emerge in these quantum soups. We know fundamental particles like electrons, they're unfriendly particles called fermions. Light, photons, these are friendly particles, bosons they're called. We're trying to see if there's some intermediate particle in there called anyons. Another thing I'm looking at is my experimental friends are looking at these condensates at zero gravity. up in the International Space Station. And then tying back to my parents, we're also looking at analogs in these systems of astronomical phenomena, like black holes, and testing some of the predictions that my late father had made. Finally, coming full circle to my mother, it's the pandemic right now, we're in lockdown, and we've started talking about the coronavirus, and I'm working with her on proteins, and in specifically applying condensed matter concepts to understand the spike protein that's there in the coronavirus. So that's just a little taste of some of what we do.
Thanks, Smitha. That's all very exciting. I'm actually very jealous of your connection to the International Space Station. My only connection is that I look at it go by sometimes in the sky. So one of the other things we'd love to hear from you about is some of your art projects. Can you tell us some of what you've been up to and maybe even what you might be planning?
Certainly. And I should say it's really a beautiful time for me because it's really bringing together, my passion for physics with my other passion, namely the arts. And again, this is a very collaborative process with scientists and artists. So two of the things to name of the many that we have, including a project-based course called Where the Arts Meets Physics, Quantum Voyages with my theater collaborator, which we created together, is the story of two voyagers going through different quantum realms, light and photons, raging Fermi seas of electrons that are actually in metal, and various lands that they go on. It's a sort of epic journey accompanied by a quantum ensemble that acts as a Greek chorus. And in moments of strife, they may be drowning in this Fermi sea, they call upon quantum sages who are real-life physicists that come onto stage and impart their wisdom in their own characteristic way and save the day. That's one piece. Quantum Rhapsodies is a sister piece that is a meditation of the quantum world through narrative, quartet music, and visuals. So these are some, but really the way all this evolves is through play and that childlike spirit. And it doesn't have to be a childlike spirit. It can actually be children. For me, the youth is very important. And my son, my 9-year-old son, for example, has always been a big inspiration. And it starts off in, spaces like this. And so shall we just explore quantum concepts together through this means of art and science?
That sounds great. Let's do it.
All right. So my son for you has drawn this. And as I told you, while humans really cannot be in quantum superpositions, you can always use these human analogies. And so, like I told you about the magnet in protons in your body, the basis of MRI, being able to point up, let's say this is the state of up, or down. This is down. This is a qubit state, in fact. What makes it really unique is that it can be up and down at the same time. And so this is a single qubit, let's say, or single quantum particle. And now, Erica, what I'd like to do is invite you to have your own quantum state. Do you have one such with you?
I do. My drawing is not as sophisticated as your son's.
The up state. Perfect. So now here's where quantum entanglement happens, what Einstein calls spooky actions at a distance. So we've come together and now we can get into a correlated state. We have an interaction together. Maybe we talk about the pandemic. So when you're sad, I'm sad too. Or maybe we talk about the marvels of science. So when I'm happy, you're happy too. And so now we've gotten into this entangled state, but the point is each of us can be in a superposition of being happy and sad at once. The only thing is we're correlated now, and we can go far apart. In reality, people have done this at the scale of the Earth itself, but let's pretend that I've gone to the moon. Here's the moon.
Once again, I'm jealous. I wish I could go to the moon.
Maybe the Earth. That's a fine place to be. And now, here's the thing that's the spooky actions. until I make an observation, I'm in the state of being both happy and sad. But the moment I make an observation at my end, boom, I turn out to be in the sad state. But here's the thing that's really amazing. Because we are quantum correlated, without even telling you anything, you there on the earth, the moment I make an observation on the moon of my state, immediately collapse on to the same state, sad. Or it could have been the other outcome, which I think is the better one. If I observe myself as being happy, voila, instantly, faster than how light could travel between us, we are in the same state. This is spooky actions at a distance for you.
Fantastic. Thank you so much for that analogy. Smitha, it has been wonderful having you with us on Quantum Connections. I will put several links in the description that go to some of Smitha's research work as well as her art about quantum mechanics. And thank you for joining us all today on Quantum Connections.